Hello dear students, program B.Sc, subject Mathematics, paper 1, semester 3, unit 1, Mathematical Logic. The topic which we are going to discuss today is Rules of Inferences and Mathematical Structures, presented by Srimati Ashwini S, Assistant Professor of Mathematics. Now let's see what argument is. The compound proposition of the form P1 and P2 and P3 and so on Pn implies Q is called argument, where P1, P2, P3 and so on Pn are set of propositions. These are called as premises, and the proposition Q is called conclusion of the argument. It can be written as P1, P2, P3 and so on Pn, therefore Q. So to say this in a simpler way, what we are going to do is we are going to consider set of n propositions denoted by P1, P2, P3 and so on Pn. These set of propositions are called as premises, and we are going to take another proposition capital Q, which is known as conclusion. So the n propositions are known as premises and the other proposition capital Q is called conclusion. These n propositions are connected by the and symbol, and then we use an implication to Q. So if you have to write it in a symbol ways, what we have to do is we will be writing P1, P2, P3 till vertically n, and then we draw a line and then say therefore Q. This is as well as saying as P1 and P2 and P3 and so on and Pn implies Q. Now let's see what is a valid argument. The argument P1 and P2 and P3 and so on Pn implies Q is said to be valued argument whenever each of the premises is true and Q is true, which means to say, we have considered n sets of premises, right, which are P1, P2, P3 and so on Pn. Each of these should have true values, and the other proposition which we are taking capital Q, that should also be true. That is, P1 and P2 and so on Pn is true when Q becomes true. Now there are 6 different rules of inferences which are very important. The first rule says rule of conjunctive simplification. So here what we have to do is we will be considering 2 propositions. So for any 2 propositions P and Q, if P and Q is true, then P is true. That is, we will be taking 2 propositions and I am using the logic connective and if everything is true, then according to the rule of conjunctive simplification, P should also be true. In symbols, we will be writing this as P and Q implies P. The second one is known as rule of disjunctive amplification. Now disjunction is or and conjunction is and. So the rule says for any 2 propositions P and Q, if P is true, then P or Q is true. So if to write it in symbol, it says P implies P or Q. The third one is known as rule of detachment or modus ponens. Here also we will be considering 2 propositions P and Q. For any 2 propositions P and Q, if P is true and P implies Q is true, then Q is true. So here we are considering 2 different propositions. We are using a logical connective and then also a logical connective for the conclusion. So in symbols it is P and of P implies Q implies Q. The fourth one is known as rule of disjunctive syllogism or modus tollendo pons. For any 2 propositions P and Q, if P or Q is true and P is false, then Q is true. Now instead of saying P is false, the other way of saying is negation P is true. So that the same rule can also be written as if P or Q is true and negation P is true, then Q is true. There we have taken P is false. The other way of writing it is negation P is true. So in symbols it becomes P or Q and negation Q implies Q. The fifth one says modus tollens, and this says for any 2 propositions P and Q, if again here we are using 2 conditions, if P implies Q is true and Q is false, then P is also false. So all the propositions which have been given as false, we will be taking its negation so that it becomes true. So in other words, the first one remains the same, that is, if P implies Q is true, and on the previous definition for this form, we have Q is false. So if I have to make this as true, we have to write it as negation Q is true. Then negation P is also true. So in symbols, this is written as P implies Q and of negation Q implies negation P. The sixth one is rule of syllogism. So here we will be considering three propositions which are P, Q and R. For any three propositions P, Q and R, if P implies Q is true and Q implies R is true, then P implies R is true. Now this is similar to a property which you have studied in relation, right? We have studied symmetric property, we have studied transitive property, we have studied, what is one more? Reflexive property. When I say reflexive, both are related to each other. When I say symmetric, X is related to Y is related to X. So when we come to transitive, A is related to B is related to C. Therefore, we say A is related to C. Now, the same concept is brought here and it says, if P implies Q is true and Q implies R is true, then obviously P implies R should also be true. So, when I have to write it in symbols representing form, P implies Q and Q implies R will imply P implies R. This becomes true. So, let's see a problem using all these laws. So, the first problem says test the validity of the argument. So, here three statements are given. So, let's look into the problem very carefully. It says, if I work hard, then I pass the course. This is the first statement. The second statement says, I work hard. The third statement says, therefore, I pass the course. So, what you have to remember here is the first two sentences are premises. The last sentence becomes a conclusion. So, if you look into these three sentences, few sentences are repeated. Now, let's check what is the first sentence. The first sentence is, I work hard. As I've told you, if you have a condition if then, what you have to do is you have to write the first proposition after the word if, the second proposition after the word then. So the first proposition here is I work hard, which we will be denoting it as P. The next proposition is I pass the course, which is Q. So there are two propositions. First one is P, I work hard. Second one is Q, I pass the course. Now let's see what happens in the next step. Then the given argument is of the form. It says if, let me go back, look into the thing again. It says if I work hard, then I pass the course. Now how do I write this in the symbols? P implies Q, right? The first statement is P implies Q. The second statement is I work hard. I work hard is P. Since these are two premises, you have to add an and symbol. So it becomes P implies Q and P. We write this in the square bracket. The last line is therefore. Therefore is always written as implies. I pass the course. I pass the course is Q. Now let's see what we have done is right. Yes. So the given argument is in the form P implies Q is the first one and P is the second one. So the entire thing is premises implies Q. Now which law is this? This is nothing but the law of detachment which we had learnt earlier. So this says by the law of detachment the argument is valid. When I say the argument is valid, it means it is true. So how do we check the validity? It says we check the validity of the argument by constructing the truth table and verifying whether it is a tautology. So we have a proposition here with different connectives here. So what we have to do is we will be considering the truth table for the entire given expression and check if the last column entries everything is capital T. If the last column entries contains all the truth values as T, then we know it is a tautology. So let us construct the truth table. You know there are two propositions P and Q. So let me write the first column as P, the second column as Q. By now you all know how to write column P and how to write column Q. The third column says P implies Q. So we have writing it as it is. And then you know the premises I've written as P implies Q and P, which I've written it in the third column. The last thing is premises and conclusion is connected by the symbol implies. So first column is P, second column is Q, third column is P implies Q, the fourth column becomes P implies Q and P, and the last one is P implies Q and P implies Q. So, you know, P implies Q is false only when the first proposition is true. Second proposition is false. That comes in the second combination. So, the second combination is F. All the other three are true. Now, let me go to the fourth column. Now, what I have to do is I have to take third column with the first column, use the logical connective AND. So, you know, whenever this AND comes, both the propositions are supposed to be true. Now, let me check which values are these. This is the first combination. So, the first combination has both as true. So, your answer is true. Rest all it is false. Now, next what you have to do, with the column 4 and column 2, you have to use implication symbol. Now, when do we use this implication symbol as false? When the first one is true and the second one is false. So, in the column 4, you have to look for T. In the column 2, you have to look for F so that it becomes false. Now, when you look into that, there is no such options. Either both are true or both are false, or first one is false and true, false and false. Now, since we do not have any false value, all the columns, the fifth column entries, everything is T. So we say the last column, which is fifth column, contains all T as truth values. Therefore, the given proposition is a tautology. Since we have written it as a tautology, I can say, hence, the given argument is valid. So what have we done here is, we had been given a statement. If I work hard, then I pass the exam. So what we do is, we first write the premises. Wherever therefore is there, that becomes the conclusion. We represent them in the symbolic form. And then we check out of these 6 inference rules, which inference rule satisfies this validity. And to check the validity, what we do is, we write the entire expression by constructing a truth table and check whether it is a tautology or not. If the given proposition becomes a tautology with all the last column entries as T, then we say the given argument is valid. Now let us see another definition known as mathematical structures. Now you know mathematics is composed of different components which are known as mathematical structures or mathematical systems. Now this consists of 4 parts. The first one is undefined terms. Second one is defined terms. Third one is axiom and postulates. The fourth one is theorems. Now let's see what are these in detail. The first one says undefined terms. As the name says, undefined, there is no proper definition or you cannot explain them in a simpler way. The word which cannot be explained in more simple words are called undefined terms. So the example which we were considering is, you know, in geometry, we keep using this point and straight line everywhere. But when somebody asks you define a point, define a straight line, we do not know the exact definition or we cannot explain it in a simpler way. You can just draw it and show, isn't it? Now let's go to the second definition. This is defined terms. Defined term is a simple statement or proposition that can explain terms in an argument or statement with no definite meaning of terms. So this has a definite structure or a definite words from which we can form a definition. The third one is axioms. Now, axioms are initial statements which are assumed to be true without any proof. That is, we just say some statement telling it is true. We never look for the proof. For example, the whole is greater than the part. You all know, for example, I'll have an apple. When I cut it into 6 pieces, you know the entire apple is much more bigger than the 1/6 part or the 2/3 part. Nobody is going to ask you the proof for it. We just assume it is true without any proof. Now let me see what is this postulate. The basic structure from which lemmas and theorems are derived are known as postulates. For example, segment addition postulate. The next one is most important, theorems. You've been studying theorems everywhere, be it mathematics or physics. Now what is this theorem? Theorems are propositions or statements constructed or formed by using undefined terms, defined terms and axioms. So how do we do this theorems? Theorems are what we usually do is we consider the given statement, we assume something and then we get the conclusions. Now where do we get all these from? We get them from undefined terms, we get them from defined terms and also we get it from axioms. The most famous example which you can all give is Pythagoras theorem. I hope everybody knows what Pythagoras theorem is, so I don't have to repeat it here, isn't it? Okay, now let's see what an open sentence is. An expression in one or more variables is called an open sentence on a set S. Now we will be considering a set S. So we are going to write an expression in one or more variables. So just remember from now on, whenever we say propositions, it is going to be in small letters P, Q, R, S and so on. Whenever I say open sentence, it should have a variable. So this will be denoted by P of X, Q of X and so on. Let me take an example. Now, since I'm writing an open sentence, I'll be writing it as P of X. 2x plus 3 is equal to 5. Another example, I'll be writing it as Q of X. X is divisible by 5. R of X, X is less than 3. So the variables which we are using here is X. So we are denoting it by R of X, P of X, Q of X and so on. Now let us see what is this compound open sentence. As I told you, when I say compound, it is 2 or more than that. So two open sentences combined by any logical connectives is known as compound open sentence. This is similar as compound connectives, compound propositions, but here we will be having a variable. For example, I have 2x plus 3 is equal to 5 and 2 is an even prime number. On the above examples, there are two open sentences. The first one is 2x plus 3 is equal to 5. I write it as P of X. Next, Q of X, I'll be writing it as 2 is an even number. Now, what is the logical connective used in this particular compound open sentence? It is AND. So, again, the references which I've used is the book of Introduction to Mathematical Logic by Elian Mendelssohn. The publication is Wordsworth and Brooks, 1987.